Welcome to lesson 9.1. Today we're going to focus on adding and subtracting polynomials. Let's start by looking at what a polynomial is. Polynomial is a monomial or a sum of monomials. Here's what you need to know. There are going to be multiple terms. Okay. Each term would be like 2 to the third, x squared, x to the fifth, and 12. Those are each terms. Okay. Some other important vocabulary is the leading coefficient. The leading coefficient is the number in front of the exponent with the biggest or the highest exponent. The highest exponent we call the degree of the polynomial. Now I mentioned exponent because in this case the 2 and the -5 are both exponents. The last vocab term is constant. 12 is a constant. It does not have a variable. If you go to the back side of your worksheet, there's a few examples about rewriting polynomials. What we need to do in these examples is we need to rewrite so the exponents decrease from left to right. That means they get lower. So in this first example, letter A, we rearrange the terms so the exponents go 3, 2, a 1, and then just a regular term without the letter. Example B, 3, 2, 1, and then a constant. Example C, 4, 3, 2, 1. Example D, 3, 1, and then a constant. So notice the exponents decrease. Some other things we picked out of each of these examples. The highest exponent, the letter 3. Example B was the letter 3. Example D was the letter 4. Example C was the letter 4, and example D was the number 4 again. The leading coefficients are those numbers in front. So like -1, 7, 3, and 5 are all what we call leading coefficients. The last thing is the number of terms. 4 terms, 4 terms, 4 terms, and 3 terms. That's just how many items there are. So that's just some basics of handling polynomials. Let's get to the real important section of 9.1, adding and subtracting. So if we want to add polynomials, we want to combine terms with the same exponent. So here's an example. Letter A. Terms with an exponent of 3, 2x to the third plus x to the third I apologize. There we are. 2x cubed plus x cubed is 3x cubed. 2 plus 1 is 3. We can also combine -5x squared and 2x squared. -5 and 2 make -3. We can combine x with nothing else, so it stays as x. And we can combine our constant of -1 with nothing else, so it stays as a -1. Let's look at example B. 3x cubed and x cubed make 4x cubed. X plus 4x is 5x. and a minus 6 and a positive 10 make a positive 4. Remember, we are adding those all together. Example C. We have 5x cubed and we have 3x cubed. When we combine those, we get 8x cubed. We have a minus 2 squared and 4 squared. When we combine those, we get a positive 2x squared. 4x cannot combine with anything else, and neither can this minus 6. So they just come with. Example D. 4y squared can be combined with this minus 3y squared to just get 1y squared. Minus y can be combined with 10y, so we get this positive 9y. And positive 2 can be combined with positive 7 to get positive 9. So those are all examples of adding. I want to just emphasize again that this was all adding exponents. There were plus signs in the middle of each set of parentheses. Let's slide down and look at example 3. This time we are subtracting. Okay, so what we can do first is distribute the negative sign. Let's zoom in on example A. On this first example, as you can see, we have these arrows going to each term. We are distributing the negative sign. The result is this negative 2x squared will turn into positive. The plus 3x will turn into minus. The minus 4 will turn into plus 4. But now we have this plus sign in between the parentheses instead of the minus. So note that this changed. Went from minus to plus when we distributed the negative sign. Now we can go back to what we were doing earlier, and we can work on combining terms with the same exponent. 4 and 2 give us 6. Minus 3x is the only x term, so that comes down. And our